Yeah.
I can.
Mm-hmm.
Is it still okay? So you can start. But João is on.
I see you on. Yeah.
You want to start, René?
Yeah, but am I on yet? Still see Jean there.
Say to start, there is a lag.
Okay. Just wait a moment.
Okay.
Okay, I think we're live now.
Yes, now you are.
Okay, well, good afternoon. Afternoon here in Oxford. It is my great pleasure to introduce to our talks here in Primate Conversations our dear colleague, Yohannes Haile-Selassie, who is one of the most prominent Ethiopian paleoanthropologists. Yohannes got his BA at the University of Addis Ababa, and he has a master's and PhD from the University of California, Berkeley, where he worked with Professor Tim White. And Yohannes did his PhD work in the Middle Awash region of the Afar Triangle in Ethiopia, with a dissertation on mammals from the late Miocene. And from that dissertation, he produced a series of very remarkable publications that came in the following years. Yohannes has played, I would say, a very, very central role in shaping the data that we have in our understanding of the first several million years of human evolution. Just a few of the contributions that he has made. He has named several hominin species, beginning with Ardipithecus cadaba, first as a subspecies and subsequently as a full species. And today, Ardipithecus cadaba may very well be the earliest hominin known. There might be some debate about this, but it could very well be, given the state of our field right now. But in addition to Ardipithecus cadaba, finding and naming this new species, Yohannes also played a major role in the discovery of Ardipithecus ramidus. If I remember correctly, he's actually the person who found the first specimens that led to the discovery of Ardi, this fairly complete skeleton that we have for Ardipithecus ramidus. Also, before finishing his PhD, he also was the person, if I remember correctly, who found the cranium that was later named Australopithecus garhi. So just in terms of some of these discoveries in the field, he has played a very prominent role. From doing a lot of work in the Middle Awash region, Yohannes later moved just north in the Afar to a site, the site of Woranso-Mille, where he has also made very, very significant discoveries. Among these, there's a well-known postcranial skeleton of Ardipithecus afarensis, which also he published as a whole volume. From this region of Woranso-Mille, Yohannes also described a partial foot that is very interesting because it's contemporaneous with Australopithecus afarensis, right around 3.3, 3.4 million years ago. But this foot shows adaptations that are more similar to those of earlier hominins like Ardipithecus ramidus. He's also named from those same sediments and time period, the species Australopithecus deiremeda. From this area, Yohannes will be talking today about early Australopithecus, and he's also played a prominent role in the initial studies in the afar of Australopithecus anamensis in the area of Asaisi. And subsequently, very recently, in 2019, he described a beautiful cranium, which is the first cranium that we have of the species that we've known for a long time, Australopithecus anamensis, but for which we have had very little knowledge about the cranial anatomy. And this cranium is probably one of the later specimens attributed to anamensis. Now, Yohannes, again, if you look at the first millions of years of our evolution, we know that Ethiopia has played a central role in our understanding of human evolution. And the Afar region of Ethiopia has played a central role. And within this, I think Yohannes's contribution is truly a remarkable one. And I would add, as a paleontologist, I would add that Yohannes is probably one of the very, very few paleoanthropologists who is intimately familiar with not only with the hominin skeleton and hominin anatomy, but he has also played a very prominent role in describing several new species of fossil mammals, new species of mammals beyond hominins, including species of suids, species of carnivores, bovids with Elizabeth Verba. So in that sense, I would say that Yohannes' contribution in terms of the empirical data that we have for early hominins is it's truly outstanding, really something admirable. But also, along with the rest of the mammal, his contribution with regard to the context of our evolution, which is really, really important, has been a major part of his research. So I would like to leave you with Yohannes. It is a real honor for us to have him talk to our group in Primate Conversations here in Oxford, and we look very much forward to hearing his discussion of early Australopithecus. Yohannes?
Okay, well, Renee, let me start by saying that this was really a very generous introduction, and thank you. You started from like the very early part of my career all the way to now, and yes, I started studying late Miocene hominins, like the earliest hominin. But then now, for some reason, that I can guess why, I'm more inclined to studying like early Australopithecus. So that's what I'm going to talk about today. But before I do that, I want to thank all of you guys for inviting me, and also Elodie, particularly Elodie, for making this happen, and all the Primate Conversation group. It's great to share some of my ideas and some of my discoveries with you guys, because it's all about our origins and evolution. And I also want to make sure that we're all, we know what's coming out of the field. All of us don't go to the field. Some of us do, but at least when we come back with discoveries from the field, we need to share it with people like you, especially people who are really interested in figuring out where we came from. So starting with latest Miocene or early hominins like Ardipithecus cadabra, I didn't know that I was going to shift my attention to the later part, like the Pliocene, until I started working at Woranso-Mille, which is about 2004, 2005. But now I'm totally into this early Australopithecus thing. And it's really interesting when you think about early Australopithecus. It is really one of the key genera that we have in our evolutionary history, which marks a serious, a unique adaptive shift from something that we saw in Ardipithecus ramidus, for example, at 4.4, to something that is totally different with Australopithecus anamensis. And when I see this reconstruction of the sequence of events from White et al., you can clearly see that the major shift in our evolutionary history is marked by the origin of Australopithecus, about 4.2 for now, but obviously it could have showed up like before 4.2. But it is really a hallmark or a major changing point that we see in our evolutionary history for a lot of reasons. And what you see here is like Ardipithecus ramidus was partial arboreal and facultative biped, whereas Australopithecus, the earliest Australopithecus, anamensis, starts with like being striding terrestrial biped, and it shows a unique adaptation or morphological change in its dentition by developing this post-canine megadontia, and also its geographic distribution now becomes wider, as you will see later. But in terms of the environment, we also see some sequence where the earlier forms, including our closest relatives, the chimpanzees and gorillas, where they live, versus where we think Ardipithecus ramidus was living and where Australopithecus animus was living. There is really a clear correlation between the shift in adaptation in early hominins. So that is why Australopithecus animus is really a critical species in our evolutionary history. So this species, Australopithecus animensis, was first named in 1995 based on discoveries from Kanapoi and Aliabe in Kenya. But at that time, it was the second earliest hominin, because we had Ardipithecus ramidus described in 1994, but it came at a time when there was a gap between Ardipithecus ramidus and Australopithecus afarensis, which starts about 3.8 million years ago. And the discovery of Australopithecus anamensis was key because not only did it connect what was earlier, like Ardipithecus ramidus, and then the famously known Australopithecus afarensis, but it also gave us some idea in terms of how this morphological changes happened. And it also showed that there was at least, terrestrial bipedality in Australopithecus anamensis that we did not see as much in the earlier Australopithecus, Ardipithecus ramidus. So when we think about Australopithecus anamensis, we got to go back in history and think about what was our knowledge of human evolutionary history, the phylogenetic relationship before the 1990s. And we all remember that Australopithecus afarensis, as the earliest human ancestor, it was supposed to be the ancestor of all later hominins, the Paranthropus lineage and also the Homo lineage and other Australopithecus. But with the discovery of Australopithecus anamensis, it takes that role, and it is now considered as the ancestor of everything else that came after 3.8 million years ago, which includes Australopithecus afarensis. So that is one of the reasons why it's really important. Do we really understand what Australopithecus anamensis was and what its paleoecology and morphology was? And as we keep finding more fossils, we're getting we're understanding it better than previously. And new discoveries always add information to what we knew about the species. And that's one of the things that I want to talk about later on. Like, new discoveries add a lot of information to what we knew previously. So all of these fossils, of course, they come from Africa, and Africa is the key to understanding our evolutionary history. And this is something that Darwin figured out like 150 years ago when he said, if we're going to find our earliest progenitors, they were going to be found in Africa. And that's because of his understanding of how the modern apes, like the chimpanzees and gorillas, are more closely related to us than any other primate. And of course, he was right. So that's why we keep looking for fossils of our ancient ancestors in this continent. And clearly, you can see where we're going to find these fossils, particularly like South Africa, Eastern Africa, particularly the Eastern African Rift System, all the way to Central Africa, like in Chad, where we now have the potentially earliest human ancestor from about 6 to 7 million years ago. But most of the work on human origins has been concentrating in Eastern Africa and also Southern Africa. Now, when you look at the distribution of this paleoanthropological sites in Eastern Africa, there is clear indication that they're all lined up in what we call the East African Rift System, right? So the East African Rift System, of course, has a very long history. It probably started in, maybe 10, 11 million years ago, even though some of the rocks in the upper arm of this rift system go back all the way to 30 million years ago. But the rift itself probably started forming about 10 to 11 million years ago. And this has impacted the topography, the ecosystem in this region because of all the rifting and volcanism, and it has created ideal environments for life to thrive. And it's no wonder that we have lots of remains of fossil human ancestors in those parts of Eastern African Rift System. And we identify like two major areas, particularly in relation to human origins research. And those are like the Turkana Basin, which Renee and everybody else works at, and this Alpha Rift System, where we have lots of paleoanthropological projects working here for the last almost 50 years now. And these two regions are really critical in understanding the origin of the genus Australopithecus, because this is where we have evidence for the earliest Australopithecus, which is Australopithecus anamensis. So that's why we've been, trying to understand the geology, paleoecology of these two regions, because they also span a very long time, and they cover a lot of time of our evolutionary history. And the discoveries from these regions have been really phenomenal. Now, I'm going to talk about just the Afar region. That's where I've been working for the last almost 30 years now, specifically sites on the western side of the rift. And this is where most of the paleoanthropological sites are concentrated on, and we can get closer. And what this slide shows you is some of the major sites where we have in the Afar Rift that have yielded remains of early human ancestors dating all the way back to 6 million years ago. And Woranso-Mille is a relatively recently discovered site. That's where I do my field research, and I'll talk more about that later on. But when we look at the evidence from the Afar Rift, it's really impressive in terms of how much we have recovered from the Afar region, going all the way back to our beginnings, like from 6.3 to 5.2 million years ago. We have Ardipithecus cadabra documented from Middle Awash and Gona. And then as we get younger, we have Ardipithecus ramidus from 4.5 to 4.3 million years ago, also known from Gona and Middle Awash. Then we have Australopithecus afarensis. Actually, we now have evidence for the presence of afarensis in the Afar region as early as 3.6 million years ago because of the discoveries from Woranso-Mille. We now have the earliest human representative of the genus Homo from about 2.8 million years ago, from also relatively new site, Lady Gararu. And we have the earliest stone tools from Gona at 2.6 million years ago, Australopithecus garhi from about 2.5 million years ago, and another early Homo from about 2.33 million years ago. Homo erectus, represented here by the Dhaka cranium from about 1 million years ago. And at 630,000 years ago, we have representatives of Homo heidelbergensis. 160,000 years ago, and then Homo sapiens dalto, and then representatives of anatomically modern Homo sapiens from 85,000 years ago. So when you look at all of this evidence, you clearly see that this region here actually represents or documents the entire 6 million years of our evolutionary history, which is very interesting. You don't really get any other area that has all of this record all in one package, which is probably about a kilometer thick sedimentary package that you have in this part of the Alpha Rift. But my work has been at Woranso-Mille for a while now, since 2004, 2005. And what's been coming out of Woranso-Mille is really impressive, not only because it opens up a new window from the Pliocene time period, particularly from a time period where we didn't have lots of early hominid fossils between 3.6 and 3.8 million years ago. But also, as Renee indicated in his introduction, there are new species at this locality, and there are like signs of overlapping hominid species living at the same time. And that's really what makes this site really interesting. So some of the major hominid fossil discoveries that we have from Woranso-Mille include a partial skeleton of Australopithecus afarensis from 3.6 million years ago. We have now a remain of Australopithecus anamensis from 3.8 million years ago, which I'll talk about in a little detail. We have Australopithecus deiremida, a new species that we named in 2015. And then the Burtele foot, which is really an intriguing foot from 3.3, 3.4 million years ago. So all of these not only add data to the human evolutionary record, but also raise new questions in terms of our evolutionary history and understanding of phylogenetic relationships, speciation, and extinction. So Woranso-Mille, this is just a topographic view of the western exposures along the at Woranso-Mille. And what you're seeing here, I'm not sure if you can see my cursor. The blue ones is where we have remains of Australopithecus anamensis from about 3.76 all the way to 3.8. And then we have Australopithecus afarensis remains from 3.6 million years here and 3.4 million years here, and then about 3.2, 3.3 million years ago here. And then the red one shows the placement of Australopithecus deiremida and also the Burtele partial foot, which all came from this region here. So there is definitely an overlap of hominins that we see at Woranso-Mille, and this stratigraphic section shows you particularly the overlap between Australopithecus afarensis remains and Australopithecus deiremida, and also the Burtele foot, which is within this time period. So clearly there is evidence for the coexistence of more than one hominid species at the same time during the mid-Pliocene. So it's really an interesting site. So the partial skeleton that we have from Corsidora, the 3.6 million year old partial skeleton of afarensis, was really significant because it represents some skeletal regions where we didn't have much, in the fossil record previously, especially the scapula. This is the most complete scapula of Australopithecus afarensis that we have in the fossil record. All we knew before the discovery of this scapula was based on the fragment that we have of Lucy. But now we can say much about the shoulder girdle of Australopithecus afarensis based on this discovery, and also about the shape of the rib cage, which is kind of interesting because people thought that afarensis may have had funnel-shaped rib cage like apes, like chimpanzees, but now we know that it was not really ape-like, but more like between human-like and ape-like. Then we have Australopithecus deiremida, which is one of the species that we named and indicates the presence of more than one hominid species living in close geographic proximity in the area of Woranso-Mille. And then the Burtele foot, which is clear evidence of that diversity with opposable big toe, which obviously we know afarensis didn't have. So this is yet another species. We haven't assigned it to any genus or species yet, but there are some indications that this could be like a relict species of Ardipithecus or some different form of Australopithecus that retained opposable big toe, and that remains to be seen when we work on the taxonomic affinity of this specific foot. Now, in terms of the earliest Australopithecus at Woranso-Mille, in 2010, when I published this paper based on two jaw fragments from Woranso-Mille that are about 3.76 million years old, it was really intriguing because they had morphological features, some of which are shared with what is known of Australopithecus anamensis from Canopoi, and some other features are more like Australopithecus afarensis. So in terms of their taxonomic identification, we were having problems like, do we call them Australopithecus anamensis or do we call them Australopithecus afarensis? Because the idea here is that if you don't have like uniquely derived or primitive features in these mandibles, then you cannot really say for sure that it's anamensis or afarensis. So what I said in that paper was, this specimens show a mosaic of features, but if we concentrate on the key traits that have been identified for Australopithecus anamensis, then I argued that this specimens actually might belong to Australopithecus anamensis. But the problem is the fossil evidence for animals that we had at that time was from 4.2 to 3.9. These are much younger, and temporally they would actually fall within the afferences range. But morphologically, they were in between. And my suggestion was like, they're more likely Australopithecus anamensis, but for now, we're just gonna put them, as Australopithecus. And of course, later discoveries, as we saw, that there was anamensis at Woranso-Mille, and now I'm convinced that the specimens belong to Australopithecus anamensis, and they might, clearly mark the youngest occurrence of Australopithecus anamensis at Woranso-Mille and in general in Eastern Africa. And morphologically, we argued that the mandible, particularly the cross-section at the P3, was a lot more like Australopithecus anamensis than any of the Australopithecus afarensis mandibles. But it was in 2016 when we found this surprising specimen from one of the localities at Woranso-Mille. This local guy who was residing in this region for almost 3 months during the rainy season, he spotted this maxillary fragment next to his goat house, and that's when he brought it to my attention when we went back to the field, and I was, okay, well, that's really good. So he took me back to the site, and all of a sudden, this is the jaw that he found, and 3 meters away from it, there was something really amazing sitting on the surface, and that's the rest of the cranium. And I picked up both specimens, and it was really a perfect fit. So I just couldn't believe my eyes, because this is really a rare discovery. You don't find things like this in the fossil record that much, particularly when you think about how old it is. And I knew it was going to be older than 3.76 because there is a tuft about 10 meters above this specimen that we've dated to about 3.76 million years ago. So I knew it was going to be old, but obviously we really wanted to make sure that we didn't leave any piece behind, because I can see on the right side, on the left side, there were some fresh breaks on the orbital region. And we really wanted to recover whatever was broken from that. And obviously, as paleoanthropologists, when you have specimens like this, it's really exciting. As a matter of fact, even if we find like a small fragment of a tooth of hominin, everybody knows how excited we get. But when you find a whole cranium like this, you can imagine how exciting moment it was for me in 2016. But of course, it comes with more work. And here is the placement of the maxilla and the rest of the cranium. And what you're seeing here is an area where the guy who found the maxilla had all of his goats living for 3 months. And this is an area where they've been doing whatever they have to do. And we had to actually sift, scrape everything. And of course, this is the deal with paleoanthropology. Sometimes you have to do things that you wouldn't normally do or you wouldn't like to do. But we had to do a lot of scraping and like sifting, which was really not really comfortable. But in terms of, because of the mission, nobody really cared about what it looked like to deal with a huge mound of goat dropping that has been accumulating for 3 months. But everybody was happy to do the work because everybody knew how significant the specimen was. And this is right before we started the sifting, which we took a lot of hours per day. And we did this for like three days. And it was really rewarding because through the pick, which we did for like 3 days in a row, we were able to recover some critical specimens from the orbital region. That was what we were hoping for, because initially it didn't have any of the orbital margins, and we knew that was going to be really difficult to reconstruct the face without the orbital margin and also part of the zygomatic. So from this peaking was when we recovered really, really critical elements from the left orbit. And as you can see here, there were 4 pieces that we recovered from the peaking. And that is what really made it more complete, giving us the shape of the orbit on the left side, And once we had this, of course, we had to take it out for CT scanning. And it was CT scanned at Penn State. And then once you have like the left side, you can mirror image the right side. And by doing that, we really came up with one of the most, beautiful crania ever found in the fossil record. And looking at it like this really tells you a lot in terms of how primitive it is, how primitive it looks, the face, the nuchal region. And obviously we were convinced that this was not Australopithecus afarensis. Having seen so many crania of Australopithecus afarensis, there was no way that this could be Australopithecus afarensis. So that's when we started really doing the analysis. But first we had to make sure that what we're dealing with is older than 3.76, and the geologists did a great job in figuring out the stratigraphy and also the characterization of all the sediments there, which was really important to understand the paleoecology in which this representative of Australopithecus anamensis lived. So what we had in the end was a minimum age of 3.76, which is the age of the tuff, which was about 10 meters above the specimen, and maximum age of 3.82 based on the date of a tuff under the deltaic sediments where the specimen was found. So we had pretty much good understanding of how old it is. So the next step was like figuring out what it is. And what we had at that time as possibilities were Australopithecus anamensis or Australopithecus afarensis. Now you might argue, why not a species different from Australopithecus afarensis and Australopithecus anamensis? Now it was clear to us that it had a lot of morphological features that are shared with afarensis, Australopithecus afarensis, and Australopithecus anamensis. And we couldn't see like anything different to distinguish it from Australopithecus anamensis or Australopithecus afarensis. So we narrowed down our choices to Australopithecus anamensis and Australopithecus afarensis. And when we did the comparative analysis, of course, there was limitations in terms of the sample size of Australopithecus anamensis, because all we have in terms of the cranial elements for Australopithecus anamensis from Canopoi include a small fragment of the temporal region, but we do have a maxilla and mandible. So to compare with something like as complete as MRD, there were like limitations, but we did our best to compare it with equally preserved areas, which include the temporal region and also the maxillary shape, which kind of tells you about the morphology of the face. So when we did that, there were lots of similarities between Australopithecus anamensis and MRD. We also looked at the canine morphology and size, and MRD has, which is what I'm referring to, the cranium, has one of the largest canines that we have in the fossil record, and you can see on this plot where it is, and it falls within the range, on the higher range of Australopithecus anamensis and outside the range of Australopithecus afarensis or Ardipithecus ramidus. But it was not just about size. There was also morphological similarities between the MRD the MRD canine and Australopithecus anamensis. And it was very different from those of Australopithecus afarensis. So all of the evidence clearly showed that this is Australopithecus anamensis than it is Australopithecus afarensis. So when we look at the detailed cranial morphology, because we have more complete crania of Australopithecus afarensis, it was really easy to compare it like with crania of afarensis like the 444 AL444-2 cranium, which you're seeing here. And we looked at the degree of midfacial prognathism in MRD versus Australopithecus afarensis, AL444. We also looked at the inclination of the nuchal plane, which is really very different when we see like the inclination on MRD, which is really primitive, versus the horizontally oriented nuchal plane in Australopithecus afarensis. And you also see in the occipital region how vertical it is in Australopithecus afarensis and more inclined in MRD cranium. So when you look at all these characters and think about which ones are the more primitive traits, and you have to go back and look at Sahelanthropus tchadensis and Ardipithecus ramidus. And what you realize is that the nuchal plane orientation, the occipital orientation, all of this, the inclined forms are the primitive forms that you see in Sahelanthropus. Unfortunately, we don't have that region for Ardipithecus ramidus, but obviously MRD retains a lot of primitive cranial features as you can see here. We also looked at some of the facial proportions, and looking at this slide, you can clearly see that MRD is a lot more like the afarensis Cranium AL444-2 in anterior view. And you can clearly see that the orbital shape is very different in Ardipithecus ramidus, which is rounded, whereas in MRD and Australopithecus afarensis, it's more angled. You can also look at some proportions of the face, the length of the face along the orbits versus the height. And you can clearly see that afarensis and MRD had a much taller face compared to Ardipithecus ramidus, which had a wider face. And that's also another difference that we saw between these. And Ardipithecus ramidus also retains that supratoral sulcus, which is missing in the afarensis and MRD specimens. But there are also some similarities with Australopithecus afarensis in terms of the position of the zygomatic, the origin of the zygomatic being positioned more anteriorly compared to Ardipithecus ramidus. So every line of evidence clearly indicated that this is best attributed to Australopithecus anamensis, and that's why that's how we published it in 2 papers in Nature. Now, the other significant thing that we learned from MRD was trying to figure out the taxonomic affinity of a frontal fragment that was found in the 1980s from the Middle Awash, which is called the Bolotli frontal. This has been dated to 3.9 millimeters. Now, this specimen has been assigned to Australopithecus afarensis, maybe afarensis, but obviously we really didn't have any comparative material from that age until the discovery of MRD. So what we realized is one of the things that characterizes MRD is the very serious post-orbital constriction that you can see here. And we tried to look at whether there was similar post-orbital constriction in the Bolotli frontal or not. And what we realized is, in fact, it's not as constricted. And it's more like the AL444-2 from Hadar. So our conclusion was that, well, this is now a good evidence for the assignment of the Bolotli frontal into the species Australopithecus afarensis. Now that brings up the question of overlap between Australopithecus anamensis and Australopithecus afarensis, and that's one of the most debated subjects in early Australopithecus. In other words, did Australopithecus anamensis give rise to Australopithecus afarensis in a linear manner or with their overlap? And the hypothesis has always been like they are anagenetically connected. But what we learned from the MRD cranium and by assigning the Bolotli frontal to afarensis is that they probably overlap, right? So when we move on to paleoecology, there is a lot said about the paleoecology of Australopithecus anamensis at Kanapoy and Alia Bay. A lot of work has been done, some of which is done by Rene and his colleagues. But we haven't done as much at Woranso-Mille, especially in relation to Australopithecus anamensis. But what I can tell you is that this specimen was found in deltaic deposits, and we clearly see that there was a lake right below the deltaic deposits. And in a lot of ways, there is a mosaic type of habitat that we also see at Woranso-Mille as much as we do at Kanapoy and Alia Bay. So obviously this early Australopithecus had a mosaic of habitats that it could exploit. But as you saw from various publications on Kanapoy and Alia Bay, Australopithecus anamensis at Alia Bay and Kanapoy was probably was preferred like more C3 habitats than C4, even though they were there. And the idea now is that maybe exploitation of C4 started about 3.8 million years ago, which means with the origin of the genus, the species Australopithecus afarensis. So obviously the MRD cranium is really significant because it gives us the first glimpse of the face of Australopithecus anamensis, and also challenges the anagenetic relationship between Australopithecus anamensis and Australopithecus afarensis. This is really important because it's challenging a hypothesis that's been proposed since the naming of Australopithecus anamensis in 1995. And clearly, this is the hypothesis where anamensis gives rise to afarensis in a linear manner. But now with MRD, what we're seeing is those two may have overlapped for at least 100,000 years, right? Now, that's what we can say based on the fossil evidence. But the one thing that we don't really know is the first and last appearance dates of Australopithecus anamensis, or even the earliest occurrence of Australopithecus afarensis, which is still in question. Of course, for the earlier origin of anamensis, there has been some work done, like modeling and so forth, including one by Bobet et al., which they think anamensis probably started about 4.6 million years ago. Other research, like Du et al., 2020, they think maybe about around 4.3. Either way, all that indicates that there was some overlap between Australopithecus anamensis and Australopithecus afarensis, and it requires finding more specimens of Australopithecus anamensis, especially from what we think is the overlapping time period. And as we keep working and finding more fossils, we might be able to show that the overlap was probably more, or reconsider the taxonomic identifications of specimens like the bulletly frontal. But we hope that we're going to find more. And with the mandibles that I mentioned at the beginning of my talk as anamensis, if they are anamensis, they're about 3.76. So that's more evidence, additional evidence to show the overlap. So at Woranso-Mille, what we have in terms of the paleoecology is, as we said in the Nature paper, in one of the Nature papers, this area, based on what we have, based on the botanical remains, is predominantly dry shrubland with varying proportions of grassland, wetland, and riparian forest. Now, we don't have as much fauna from the locality where we found MRD, but this is what we're learning from the botanical remains. And the one thing that we have to remember is that this locality was probably close to the rift margin, and there is a lot of erosion that came also from the highlands, which sample some of the temperate zone vegetation, which was also sampled in at MRD locality. But what we think is that MRD also lived, or Australopithecus afarensis at Woranso-Mille also lived in a varied mosaic habitat. And we still have to work on its dietary preferences and so forth as we keep working on this, but we haven't done that yet, but that's part of what we're gonna do next. Biogeography. Now, I'm quoting Bobet et al. Here about what they think about the biogeography of Australopithecus anamensis, and the distribution of early Australopithecus and other mammals from Turkana Basin to the Afar indicates that these two regions were biogeographically well connected in the early Pliocene, but there was an important difference between them. I agree to some degree, but it also makes me think about, like, when we talk about species, early hominid species, at Turkana Basin and the Afar Basin, we have to really think about, like, how far are these two places, and could there be, like, could they have had, like, their own evolutionary processes wherever they are, because populations of species separate at times. And I think when we look at the distribution of Australopithecus anamensis, yes, definitely there was anamensis at Woranso-Mille and Galili and Asaisi, Aramis in the Afar region. There was also anamensis at Haile-Selassie, Kanapo, and Fudges. But when you look at the distance between these two areas, it's almost 1,000 kilometers, right? Now, species move from place to place, and 1,000 kilometers may not be as too much for a species to move, like in many years, but it always surprises me, like, do we really have a good understanding of the formation of the main Ethiopian rift? Because that's something that we have to really consider. And most of, some of the main Ethiopian rift system developed, according to geologists, maybe between 5 and 3.5 million years ago. And I always wonder, could there have been like some kind of geographic barrier, between these two regions for a lot of faunal interchange not to happen? And it's all about the timing of this rift, the main Ethiopian rift. That's going to really tell us about whether there was a lot of faunal interchange between these two regions. But at the same time, I wouldn't be surprised by looking at the distribution of the later taxa, like Australopithecus afarensis, which is also found like in the Turkana Basin and even further south to Laetoli in Tanzania, and also in the Afar Rift, right? We do have all those representatives of afarensis in those two regions. We have early Homo from the Afar region at 2.8 million years ago, but there are also other species that overlap with afarensis. Kenanthropus platypus in Kenya, in the Turkana Basin. We have Australopithecus remeda in the Afar Rift. So when you think about these species, which are not like represented at both places, you start thinking, well, is there like a unique evolutionary history for these two regions? Because you have platypus, Kenanthropus platypus in the Turkana Basin, and you have Australopithecus remeda in the Afar region. So it makes me think that maybe early populations of Australopithecus anamensis isolated themselves, small populations isolated themselves and follow their own evolutionary trajectory. So I think it's a good hypothesis to think that the Australopithecus anamensis populations at Woranso-Mille were probably isolated and had their own evolutionary trajectory, which is different from the populations that were in the Turkana Basin, and some populations may have given rise to Kenanthropus platypus, because you have clearly overlap between afarensis and platypus and Kenanthropus platypus in the Turkana Basin, as much as you have overlap in the Woranso-Mille area between Australopithecus afarensis and Australopithecus remeda. So there is still a lot more work to be done, particularly clear understanding of the biogeography of this region, particularly the formation of the main Ethiopian rift. All of this will be important to understand this population dynamics during the mid-Pliocene. So I would just say, to conclude, that these earlier phases of human evolution, they're probably much more complicated than previously thought. I think we're going to learn more about mid-Pliocene hominid diversity as we keep finding more fossils. And we will also have better understanding of Australopithecus anamensis, particularly if populations of the species were actually isolated for a while and had their own evolutionary trajectory. And this is really an important subject to investigate with as we continue research into human origins. So all of this that I presented today is not a one-person job. There are so many scientists who've been participating in this project for the last 15 years. And we've been funded by various granting agencies, including my own institution, the Cleveland Museum of Natural History, the National Science Foundation, Leakey Foundation, National Geographic, Wintergreen Foundation, and PAST. All of this have at some point contributed to research at Woranso-Mille. And I also want to say that we wouldn't have been as successful as we are if it were not for the participation of the locals who do a lot of work for us, and including finding the fossil hominids, actually. And as we keep continuing work with these people and finding more fossils, they're doing their share in terms of understanding our evolutionary history in the last 4 to 5 million years ago. And I think that's about it. Thank you.
Thank you, Yohannes, for a really interesting talk on an absolutely fascinating topic, one of my favorite topics on Earth. But thank you very much. We have in the YouTube channel several questions that have appeared from various people, and if I may, I'd like to ask you a few of these. I hope we have time for several, but one of the first questions that we have is the evidence that you presented for early Australopithecus afarensis based on the Belodili cranium, that would show then some overlap between afarensis and anamensis. Is it possible or plausible that with the Belodili cranium, what we have is simply variation within the species anamensis, and that this wouldn't necessarily constitute overlap, but simply we're looking at just variation over time within this evolving lineage? How strong is the evidence then for overlap in relation to the possibility of more of a cladogenetic or anagenetic event?
That's a very interesting question, actually. Yes, we did ask ourselves the same question, right? So what we're seeing here is one of the key cranial features, which is postorbital constriction, right? So we see it in the MRD, but all of the crania that we have of Australopithecus afarensis, they don't show that. They don't show as much postorbital constriction as we see in the MRD cranium, nor does the Belodili frontal show that constriction. So our analysis was, if we don't see it in any of the more complete afarensis crania, then that is a classic character. More broad constricted area is characteristic of afarensis. So because we see that kind of characterization for the Belodili frontal, that's why we said it could be like the earliest Australopithecus afarensis. But could it be variation within Australopithecus anamensis? Could it be like a more derived version of Australopithecus anamensis? That's quite possible. But when it comes to overlap, we still think that even if the Belodili frontal is not Australopithecus afarensis, think about the Australopithecus afarensis hypodyne from Laetoli. Laetoli afarensis is from starts at 3.8. We have specimens that are assigned to Australopithecus afarensis as early as 3.8 million years ago. So either way, there is overlap between the two species. So we can't really falsify that yet, even without the Belodili frontal. But I'm also saying that the specimens that I talked about, like the mandibles at the beginning of my talk, these are from 3.76, maybe it's 3.7, right? And not only those two specimens, but we've also been finding more of that age from Woranso-Mille, which clearly shows that they're better assigned to Australopithecus anamensis than they are to Australopithecus afarensis. So what that means is if the overlap was not between 3.8 and 3.9, it would be between 3.8 and 3.7. So either way, there is clear indication that those two, even though we can't falsify that they were ancestor descendant, which I think they were, but they did overlap. And in a lot of ways, when we think about our evolutionary history, we can't think about just anagenetic evolution throughout our evolutionary history. Now we have a lot of indications that ancestors and descendants were coexisting for some time, right? And it's not unnatural for those ancestor-descendant relationships. So I think as we move on, as we find more fossils, we're going to probably strengthen that overlap by describing more fossils from slightly younger deposit that clearly overlap with Australopithecus afarensis.
And just to follow up on that, do we have at the moment any major gaps in the story here, the transition anamensis, afarensis? Are there any major temporal gaps? You've talked about 3.76, 3.8. Do we still have some major gaps that need to be filled that may make it difficult to understand this relationship better between these two species?
So yeah, with the hypothesis of ancestor-descendant relationship between anamensis and afarensis, previously, before all this hominins started coming out of Woranso-Mille, the major caveat was the lack of fossils from 3.6 to 3.9, right? Now, with all the discoveries from Woranso-Mille, which fill that gap more or less, from 3.6, we have fossils all the way to 3.8. But now I think the gap would actually be from 3.8 to 3.9. We need to link that time period so that we have the whole sequence. Otherwise, what the gap was like between 3.6 and 3.8, but now it's like between 3.8 and 3.9. And that would be very, very critical, especially for the point that you raised about the Belodili frontal, right? So if we have anamensis that has more bolotely frontal-like morphology from 3.8 to 3.9 from other localities or even from Middle Awash, then that would be really great if we can associate that morphology that we see as a derived trait within Australopithecus anamensis. So I think if there is any gap in the fossil record right now, it would be between 3.8 and 3.9. That's how we've narrowed it because of the discoveries from Woranso-Mille.
Thank you. And I think João will continue with next
Yes.
question, if you may.
Thank you so much, Professor Yohannes, for the excellent talk. Keeping up on the topic of the gaps, another question we got is, are there fossil samples in the Afar between Ardipithecus ramidus at 4.4 million years ago and the earliest anamensis at 4.2 million years ago? So similar question.
I would say yes, but nothing has been published yet. And that locality would be a new site called Galilee. It is like on the southeast of Middle Awash, where Ardipithecus ramidus was found. So if we have any Australopithecus anamensis prior to 4.2, somewhere between Ardipithecus ramidus and Australopithecus anamensis, that would probably be the site. Because I know they have sediments that are about 4.3 million years old, going all the way to 4.5. So that's one area. The other area where we could potentially find Ardipithecus ramidus would be from Gona, which also has sediments that are between 4.3 and 4.5. As a matter of fact, that's the age constraint for Ardipithecus ramidus from Gona, between 4.3 and 4.5. So I wouldn't be surprised if we find anamensis from there, okay? Because the first appearance date for Australopithecus anamensis is still unknown, and Renee suggested probably it may have showed up around 4.6 million years ago. It could go as far back as 4.6. Others think maybe it showed up around 4.3. So we still, the more fossils we find, the better. But there are like predictions in terms of how far it may have gone in the fossil record, and I think 4.6 is going to probably be like the earliest possible that Australopithecus anamensis showed up, which then indicates that it overlapped with its potential ancestor, Ardipithecus ramidus. So that brings me to my initial point, where all of these early hominin ancestors and descendants must have overlapped a lot of times. And we've seen the overlap is not an issue now, because we see it in the Middle-Pliocene, we see it in the Pleistocene with like Paranthropus and Homo running around at the same time. So it's really, all of these discoveries are actually reshaping the way we think about our evolutionary history, the way we think about phylogenetics, the way we think about speciation and extinction, all of those things. So yes, indeed, finding fossils, new fossils helps a lot.
Very good.
Yeah, and related to, oh yeah, may I? Sorry. Related to that, we also had a question about like overlaps and the speciation mechanisms, and it was specifically about the budding speciation. So when the ancestor gives rise to a single new species while it continues to evolve. And do you think this is a mechanism that accounts for the persistence of Australopithecus anamensis and the origin of Australopithecus afarensis?
Now, it depends on where we think Australopithecus afarensis originated, right? Because if you look at the fossil evidence, we have the earliest Australopithecus afarensis from, let's say, Laetoli, about 3.8 million years ago. Now, we have afarensis at the earliest afarensis in the Afar basin. If we don't consider the bolotely frontal as afarensis, then it will be 3.6 million years ago, right? But you have anamensis in those two places. So the key thing is, where did afarensis start? Did it start in the Turkana Basin or further south, or did it start in the north in the Afar Basin? So all of that speciation idea is dependent on how we determine where that species first appeared in the fossil record. To me, it looks like maybe Turkana Basin, and Australopithecus anamensis in the Afar region might have been doing something else, because I think about Australopithecus deiremida and think, where did that species come from, right? And I can tell you that there are some similarities of Australopithecus deiremida with Australopithecus anamensis. And could it have, come from Australopithecus anamensis populations at Woranso-Mille, right? So if you what we said in the paper, in the MRD paper, the 2019 paper, is we clearly stated that Australopithecus anamensis is definitely the ancestor of Australopithecus afarensis. But Australopithecus afarensis may not have evolved from anamensis populations at Woranso-Mille. That's what we said in the paper. Okay, so what we think is that because we have a lot more evidence of other taxa from Woranso-Mille, we think that the anamensis population at Woranso-Mille may have had its own evolutionary history separate from the populations down in the Turkana Basin. And we think that maybe the Remeda and maybe the Burtalephid, they're all linked to the populations, earlier populations of Australopithecus anamensis at Woranso-Mille. So that's why fossils are always exciting, but they always, challenge the hypotheses that we put forth, like in the past, based on whatever fossil evidence that we had in hand. So it's really exciting to study human origins.
And if I may, another question, you've mentioned De Remeda and the Burtalephid and so on, and adding to that some of the species from the Turkana Basin, so Kenyanthropus. Then we have possibly in Chad, perhaps a different species of Australopithecus. You've written about the diversity of hominins in the Pliocene, and this is clearly a very important topic, something that seems to be very strong in terms of perhaps we cannot talk about an adaptive radiation, but certainly a diversification. Now, I'd like to hear a bit more your thoughts about this diversity, but also related to this is the question of the Burtalephid. And one of the members of the audience here has asked whether the Burtalephid itself might belong to a different kind of primate, not necessarily a hominin. And what do you make of that? Are we trying to put all of these into hominins where they may be perhaps outside of the hominin clade?
That's a very good question. Speaking of the Burtalephid, the reason why it can't be a non-hominin other primate is because we know the feet of primates in a lot of ways, and we know the morphology of their big toe, all right? None of them shows any morphology like hominins, okay? They're really, in terms of their proportions, their length and everything, they're different. So there is no way that we could have assigned the Burtalephid into a primate, a non-hominin primate. So there are clear indications of the association of this foot with hominins. Secondly, think about Ardipithecus ramidus, right? So if Ardipithecus ramidus is a hominin, then Burtalephid is a hominin. There's no doubt about that. But the key thing is we don't see non-hominin primate-like morphological features on the Burtalephid. And all of the associated specimens that we have from the locality, they're clearly hominins. So unless that foot showed up by miracle and everything else is hominin but not the Burtalephid, I don't think so. So, but mostly based on morphology, I don't think it would have belonged to any non-hominin primate.
Thank you. Jean, do you have a...
To follow up on that question, so when the Burtale's foot was discovered, it was hard to understand where it would fit in the hominin tree. Have you updated your views recently on where it might fit based on the most recent discoveries from Woranso-Mille and where else in Ethiopia?
You mean in terms of its phylogenetic relationship?
Yeah, in terms of the taxonomy.
Taxonomy, okay. Well, that's a good question. We were really cautious in terms of assigning it to anything because it's really important to actually understand what species it belongs to, but we cannot rule out that it might belong to Australopithecus de Remeda, for example, because all of the specimens that we have from the locality where the foot was found are assigned to Australopithecus de Remeda. But the key question is, why would a hominin like Australopithecus de Remeda have an opposable big toe, right? Because we think that it's already, we've already evolved more terrestrial bipedality, which would require, adducted big toe. But is it like a relict species of something like Ardipithecus ramidus that persisted all the way to the mid-Pliocene? Or are we actually seeing like opposable big toe persisting throughout our evolutionary history until our forensics, right? So one of the key things is we don't really know the foot morphology of Australopithecus anamensis. That's what really makes it very difficult, because evidence for bipedality, human-like bipedality that we have for Australopithecus anamensis is based on a tibia from Alia Bay, right? So if we found the foot of Australopithecus anamensis from Canopoi, and it is more like that of Australopithecus afarensis, then that would clarify the taxonomic affinity of the Burtele foot. But right now, you cannot really rule out the possibility of Australopithecus anamensis having a foot like the Burtele foot. Because just if you go back in our evolutionary history, Ardipithecus ramidus had it, right? Ardipithecus ramidus had opposable big toe. So you can't really falsify until you find the foot of Australopithecus anamensis that anamensis had a opposable big toe too. Because right now, tibia by itself, as we have seen from South African hominins, the tibia by itself is not going to tell you whether the foot has, opposable big toe or adducted big toe, right? You have to find the foot itself for the species that we're talking about. So I think its taxonomic affinity is still in question, but I wouldn't be surprised if it's somehow related to anamensis.
Very good. Another question here. Staying on the topic of the diversity of these hominins that you have so well demonstrated, much of this diversity would have to be based on ecological differentiation, very likely behavioral and locomotor differentiation within the region, within the Afar region, but also more broadly across Eastern Africa. Aren't there approaches that paleoanthropologists may want to take alongside primatologists observing modern day diversity of primates in modern ecological contexts, using different locomotor repertoires and differences in ecology that would help us think more clearly about this diversity that we have in the Pliocene hominin fossil record, this diversity of adaptations?
That's correct. I mean, the modern forums, the modern habitats and environments inform us about what probably happened in the past. But you asked me like the exact question that we're trying to address right now, because okay, there was diversity, right? So the key question that we're working on right now is how did they manage to coexist, right? So that brings us to like, was there like niche partitioning, or was there like, plenty of resources that they didn't have even to compete? All of these questions are what we are trying to understand, because that helps us not only in terms of where they were living, but also the reasons for the speciation, the reasons for the extinctions that probably took place. So actively what we're working on right now is addressing that question of like, how did they manage to coexist in Woranso-Mille and not others? And Hadar, one of the richest sites that we have from the Pliocene, every hominid that is there is Australopithecus afarensis. Whereas at Woranso-Mille, which is only 30 kilometers north, we have all this kind of diversity, right? So that's why we are asking, like, how did they manage to coexist at Woranso-Mille and not at Hadar? And this is really a very important question. And we've started thinking about, like, the role of, like, plate tectonics, the rifting, and the basin formations. All of that will have effect on how these ecosystems are being, like, shaped, reshaped, fragmented, and those kinds of ecological or natural phenomenon might have been more at Woranso-Mille than they were at Hadar. So those are the kinds of things that we're investigating now. And if we can have a better understanding of how we can connect, like, all of this dynamics, like tectonics, rifting, and basin formations with like speciation and extinction, I think that would be, one step ahead, to understand what's going on during the Middle Pliocene in our evolutionary history.
Thank you, Yohannes. I hope we have time for one more question, perhaps.
Okay, one more question, sure.
Okay, João, you can take that.
Yeah. So since we are talking right now about paleoecology, one of the questions we had was if there is any work done on other species in the same region, which allows proposing hypotheses on the connectivity of populations through the rift.
Well, we haven't done much in that area because Woranso-Mille is relatively a new site, and what we've been doing in the last 15 years is actually having a good understanding of the stratigraphic sequence, the age of these deposits, because we're getting into a new territory, right? Like particularly a territory that we haven't had a lot of knowledge on. So most of our work has been concentrating on like the geology, the stratigraphy, but in the meantime, we're finding all these fossils and we have to, keep describing them. So we haven't had a chance to actually delve into like that aspect of the research yet. And that's why we still have a lot of work to do at this locality. But I think eventually we're gonna tie up all of this sequence because we have sediments ranging from like 3 million years all the way to 3.9 million years, right? So we're talking about like 900,000 years of our evolutionary history represented at Woranso-Mille. And it looks like a very different history than what we have from the Turkana Basin or the rest of the Afar region. So it's really, it's going to take some time, but eventually it's going to be one of the sites that has, a lot of significance in mid-Pliocene human diversity and hominid, speciation and extinction. But the work is still ongoing, and hopefully we'll have more data as we continue the research.
Well, Yohannes, on behalf of our lab, I wanted to give you a big thank you for this excellent talk, very stimulating, a lot of thoughts that we'll keep discussing, and I hope that soon we can continue this conversation with you. It's been a real pleasure to have you, and thank you for taking the time to speak with all of us. And again, I hope we do get to continue the conversation live sometime in the near future. So thank you very much.
Thank you for inviting me, and I really enjoyed giving the talk. All right, bye-bye.
Well,
Thank you. Just a reminder for everyone that is listening that next week at the same time, Tuesday, 4 p.m. GMT, we'll have Nicholas Langlitz with the topic Making Up for a Missed Encounter, Why Cultural Primatologists and Cultural Anthropologists Didn't Get to Talk.